Hello, this is Jack Gassett with Gadget Factory, and we're moving on to part 3 of the Sump Logic Analyzer VHDL code overview. And we left off just starting to talk about the memory options, and just diving right back into that. Basically, we have several different options that are controlled by that memory depth generic that can be passed in from the command line. And so if a value of 6 is passed in, then it's actually going to implement this using this core. Sorry, I got a little tongue-tied there. So the BRAM memory is actually implemented using a Xilinx core wizard, and in the case of 6, it will use this, and we can double click on the wizard and take a look at the parameters that are defined for the 6K depth memory. So basically this is the block memory generator. It's set for single port RAM, minimum area. We have a write width of 34 bits. We only have 32 channels, but 34 includes the parity that's available to us in the block RAM. Instead of letting it go to waste, we can use the 33rd channel for the RLE. And with the amount of block RAM we have available, we can get, if we have 34 channels, we can get a write depth of 6K. None of this is really important, as is this. And here we see the summary. We have 12 block RAMs available to us, and we can see that with the configuration we have set up, it uses 12, so we look good. Alright, so moving forward again, let's take a closer look at the SRAM_BRAM module, because it's actually this module that instantiates these cores. So there's a little more to be seen within this module, and this uses generics to pass in to basically parameterize once again which core we're going to implement. Going down, this is the same kind of structure where you define your components and then you get to your actual code or the architecture. And this is really kind of the only thing of interest in here, which is the address controller. So it's here in the SRAM/BRAM module that incrementing and decrementing the address counter is controlled. So the core actually handles sampling the data, and it actually handles at what speed the data is going to be sampled. It passes the data, the sampled data, out of the core and into the SRAM module, and it's the SRAM's module's job to keep track of where in memory we are currently writing, the current sample to. And it does this by keeping a counter, and when it's writing, it increments that counter, and that counter is actually just it's the address as well. So it increments the address, and when the core says, okay, I'm writing right now, that address continues to increment with every clock cycle, and as it's incremented, the data gets written to the actual underlying memory. Now if the core is told that it needs to be reading back the samples and passing it out through the UART or the SPI, it decrements the address and passes that, it connects the SRAM at each clock cycle. And I'm about out of time again.